them are stationary and in motion. Now we have to discuss about, after knowing what is the rest. Rest is the object in which there is no change in position with respect to time. Now motion is just opposite to the rest. Motion is the moment. Motion is the moment of a body with respect to time. When position change of an object continuously with respect to a stationary object from a reference point is said to be a motion. For example, a moving car, walking of human being, the revolving of needle of hours, minute and second, these are the motion. Hence, motion can be defined as when a body travels a distance by the interval of time from a reference point is said to be a motion. Hence, motion is to change in position upon taken time or distance traveled upon taken time is to according to SI unit, it may written as meter upon second, that is m by s, meter per second. It can be written as ms to the power minus 1. But in CGS, centimeter gram second, the unit of motion is cm by s, that is cm per second or cm s minus 1. Therefore, dimension of motion is to meter by second. Dimension is only knowing by the SI unit, not the CGS. So dimension of motion is here the SI unit m by s, that is meter can be represented by L and second can be represented by T. Therefore L T minus 1. Hence dimension of motion is m L T minus 1, where m is not present, so it is m naught L T minus 1. Dimension of motion in which only present travel distance and second not mentioned in of their mass. Hence mass becomes 0, length L time per second, that is m naught L T minus 1. Motion of any object is a scalar quantity because there is no mentioning about a fixed direction. Motion is only change in position within a period of time. So there is no direction is mentioned. Hence, physical quantity of motion is a scalar. Is a scalar. Now we have to study about the types of motion. Types of motion. There are two types of motion. First is uniform motion. Second, non-uniform motion. Motion. Number one, uniform motion. एक समान गति. Uniform motion. In this motion, two things, that is that is time period and the travel distance. Time period travel distance are being equal. Hence, uniform motion can be defined as a body is said to be in uniform motion if it travels equal distance in equal period of time. There is time period and the travel distance difference are equal in each and every step. So it can be defined by the travel distance and time period are being equal. For example, a car traveled with constant speed equally in change in position by the equal period of time. Suppose 10 meter per second is the speed of a car. It means car will cover it equal distance 10 meter in 1 second. In 1 second. So the motion of the car is said to be यूनिफॉर्म मोशन कार एक समान गति में है। कार एक समान गति में है क्योंकि कार के द्वारा ट्रैवल किए गए दूरी और लगे टाइम पीरियड दोनों बराबर पीरियड और डिफरेंस से हो रहे हैं। नाउ वी डिफाइंड इट बाय ए ग्राफ। सपोज a distance and time table is as follows: time, distance, time is mentioned in second and distance is mentioned in meter. Suppose a car travel 5 meter within 1 second, and next step it travel 10 meter in 2 seconds, 15 meter in 3 seconds, 20 meter in 4th second, 25 meter in 5th second, 30 meter in 6th second. This is said to be uniform, that is, a speed or motion equal to d by t, travel distance upon time. Travel distance here is 5 by 1 is to 10 by 2 is to 15 by 3 is to 20 by 4, that is so on. Their result will be 5 meter per second, 5 meter per second, 5 meter per second. The motion of the body is 5 meter per second in each and every junction, so the motion is said to be uniform. Graphical representation between dt, graphical representation at first we know always distance is taken vertically in y-axis, where time is taken horizontally on x-axis. So we indicate horizontal axis x and vertical axis y. This is time in second, and this is distance in meter. Distance can be taken on y-axis and time is taken on x-axis, where both the axes joint, that is origin O, now indicates on x-axis according to the table 1 second, time second, 2, 3, 4, 5, 6. This is the time period in second, and on vertical axis distance is mentioned, that is 5, 10, 15, 20, 25, 30. From the origin, a car is started and taken time 1 second, travel 5 meter distance, that is this. Means a car taken the distance 5 meter within a period of 1 second. Similarly, in second interval of time, car travel a distance 10 meter in third period of time called travel 15 meter and so on. This represent any uniform motion of a car within the equal period of time and travel equal distance. Here OA represent uniform motion by the car. The straight line OA represent the uniform motion. Another example, after any distance, suppose time period are different time period but in equal difference, and travel distance are different but in equal difference, is travelled by a body is said to be uniform motion. Now the second is non-uniform motion. Non-uniform motion has equal distance according to uniform, equal distance and equal interval of time, but in non-uniform there is opposite relation between the time period and the travel distance by a body from a reference point. So how can one define non-uniform motion? Non-uniform motion of a body is said to be as the when a body is non-uniform in motion, then it travel equal distance in unequal interval of time period. It means a body is said to be in motion if it travels equal distance in unequal interval of time it indicates just opposite to the uniform motion. Equal distance can be traveled by the body in unequal interval of time. Time is being maximum taken in non-uniform motion. For example, from a reference point a body travel 5 meter and taken 2 seconds. To reach a point B, and then it travel 5 meter to reach at C point in 1 second. Gradually, it reaches at D, E to cover 5 meter, 5 meter within 3 seconds, 5 meter during 4 seconds. Here, the distance traveled d by t is similar 5 meter and 5 meter, where time is taken different. At first, A to B, AB equal to 5 by 2 meter per second. B to C 5 by 1 meter per second, that is 5 meter per second. C to D 5 upon 3 meter per second, and D to E 5 by 4 meter per second. Mathematically, AC took the interval of time 5 plus 1, 5 plus 5 upon 2 plus 1, that is 10 by 3 meter per second. There is difference in interval of time and equal in travel distance. That body is said to be non-uniform motion. Hence, now again repeated the definition of non-uniform motion is said to be if a body travel equal distance in unequal interval of time period. Let some example. It may produce zigzag mode of motion, curve mode of motion, and so on. For example, as the tabular value you have see here, by the graphical representation, that is time in second, distance in meter. Meter can be placed on y-axis and time is placed on x-axis through a certain point. A car travel in 1 second 5 meter, that is at this point. Again car in second interval of time it possesses 8 meter. It means the same mode of traveling by the car. In third second it covers 9 meter, and so on. In fourth second it covers 15 . Meters in fourth second. Now if we join from the origin, the traveling path of the car is not in a straight line, it is curved at maximum point. It denotes that the motion of car is non-uniform and so on. Suppose in another graphical representation between distance and time, x-axis and y-axis. Time period is here 1, 2, 3, 4, 5, 6. In first interval of time, the 1 second a car travel one, 2, 3, 4, 5, 6, 5 meter a distance. 5 meter a distance, but in second interval of time it travel 3 meter. In fourth meter, the motion of the car become much larger and come to the 1 meter per second. And in 5 meter, the car is stopped, 0 second. Therefore, the graphical representation clear about the curve path. So, motion by the car is non-uniform. There are some differences in non-uniform motion and uniform motion. That is the definition about the motion